David the Science Guy.
David the Science Guy.
David the Science Guy.
So, everyone knows who Newton is, and if you don't, clearly you don't know science. Newton came up with 3 different principles of motion. He has 3 different laws that explain why things are. So, the first law is that a property of matter remains in an existing state of rest or uniform motion in a straight line unless acted upon by an outside force. Here's an experiment you can try at home to demonstrate Newton's first law of motion. So you take a string and you tie it to either a block or any object that it'll stay around, and you get a piece of tape. Then you tape the string to the wall at the top so that the object hangs like so.
Yeah, it does.
And then Dave, do you want to demonstrate pulling it out? So what you want to do is you want to pull the object out and then release it so that it hits the wall. And this shows that the wall, being the outside force, acts on the moving block and causes it to stop moving.
Yeah. This is Newton's second law equals force, mass times acceleration.
Yep. So in this experiment, we're going to be having 2 different size balls that are different masses. And we have measured out a section of a staircase. We're going to let them roll down the staircase, and we're going to see how acceleration has changed between the 2 different masses. And we're keeping force the same because we're just letting them roll down. So we're going to do 3 different trials, timing each one to see if there's a trend. The 2 balls we'll be using, clearly you can see they're different masses. This one is really hollow and light, and this one is a volleyball.
Yeah.
So and the space we measured out is right here with the tape, here to down there. So we're gonna time them rolling down. So for trial 1 of the volleyball,
In 3, 2, 1.
so it was 2.15.
Got it. We did 3 trials, and the volleyball is the distance. Like the first trial for volleyball is 2.15, and the second trial is 3.73 for volleyball, and the third trial for volleyball is 2.25. And then the first trial for the wiffle ball is 4.23. The second trial for wiffle ball is 4.83. And the third trial is 3.28.
So first, after taking the times for each trial, we collected data on the velocity. So we figured the volleyball for the first trial, the velocity was 1.47 meters per second. For the second trial, the velocity for the volleyball was 0.85 meters per second. And then for the third trial, for the volleyball, the velocity was 1.40 meters per second. Then for the wiffle ball, the first trial, the velocity was 0.75 meters per second. For the second one, it was 0.65 meters per second. And then for the third one, it was 0.96 meters per second.
We collected the data for force, and the formula we used is F equals mass times acceleration. We found out that the mass of a volleyball equals 0.27 kilograms, and the mass of a wiffle ball is 0.045 kilograms.
So with the masses of each and the velocities, we calculated force. So the force for the volleyball for the 3 trials was 0.40 newtons, 0.23 newtons, and then 0.38 newtons. And then for the wiffle ball, we found that the forces for each trial were 0.034 newtons, 0.010 newtons, and then 0.043 newtons. So in conclusion, the volleyball had more force going down the flight of stairs than the wiffle ball. So this is Newton's third law, and Newton's third law is,
Every action that equals a force.
and so for every action there's equal and opposite reaction. So, an example of Newton's third law is shown by this. As Quinn jumps up, the board goes down. Can you do it a couple more times? Good job.
They see me rolling, they hate it.
I'm wrong, guys. It's not running right? So I'm going. It just took off. Dude. Oh my god. It's not stopping. It's not stopping. Oh my god, dude. My snowmobile just drove away. Holy. What just happened? Oh my god, I just got this on camera. I'm going in my house right now. Oh my god. This